In this video, we are going to answer 2 of the questions from section B of 2024 paper 2 mathematics. Okay, this is where you get to choose questions. So we are going to answer question 9 and question 12. So we are going to start with question 9. So here is question 9, and of course we can get into answering questions. The diagram below shows the triangle PQR, in which PR is equals to 8.9 centimeter, QR is equals to 12.5 centimeter. Angle PQR or PRQ is equals to 1/3. As you can see from the diagram, here is QR, and here is PR. So these are the distances that you are seeing, and of course the angle that is PRQ is 130.6 degree. The first question is calculate PQ. So we are calculating PQ, and this is the distance. Okay, so we are calculating the distance PQ. So how do we calculate the distance PQ? And of course, just to give you the topic, this is coming from trigonometry. And of course, I'm sure you know by now, you know of the sine rule, and of course cosine rule. I have some of the videos that I created just on this particular part that is under trigonometry, but I'm going to explain here, okay, the rule that we are going to apply. So the rule that we are going to apply is cosine rule. This is because we have 2 sides and of course an included angle. That is one of the conditions in which cosine rule is used. The other one is when you have 3 sides without an angle. So let us say this side was 10 centimeter without this angle. Still we are going to use cosine rule. Generally, cosine rule is a square equal to b square plus c square minus 2bc cos a. Okay, so that is general cosine rule. Now, one thing that you should know also is that opposite of p right here, this is small letter p. Opposite of q, this is small letter q. Then opposite of r, this is small letter r. So small letters represent distances, and of course the capital letter represent the angle. So the angle here, it is r, okay? This angle is sitting at r here. I guess that you've gotten that part. So we have this, and of course we have that. Then we have small letter r. And now the part PQ. PQ is just the same as the r. So to put to try and write cosine rule in relation to the question that we are given, it is going to be r square equal to p square plus q square minus 2pq cos, what is the angle? Angle r, which is cos r. So this is the one that we are going to use. Okay, this is the general one that you need to know. Okay, now let us fuse in what we have. So we can just take note here, p is equals to, that is small p, is equals to 12.5 centimeter. Small q is equals to 8.9 centimeter. And of course, r is the one that we are finding. Okay, r, which is the same as the pq. Take note of that. So now, we can replace, what is our p? Our p is 12.5 square plus our q is 8.9 square minus 2, then multiply 12.5 multiply 8.9. Okay, then cos, what is the angle? Let me just, okay, 130.6 degree. That is the angle. Now, if we are to punch here, this first part, if you are to punch, it is going to give us the first part here, just the whole of this one, it is going to give us 235.46. Okay, I guess that is what it is giving us, 0.6. Then of course plus the whole of this one is going to give us 144. Okay, 144.7 97. I mean punching together with cosine here. Okay, so it's going to give us 144.7972 then of course 633, okay, triple three or double three, okay, that is what it is giving me. So be able to confirm. Then if you add these, you're going to have 380.257263, okay. Now what we are finding here is r square. So r square, okay, so r square we said is just the same as r is just the same as pq, so you can say pq square is equals to, okay. So now the square root of, let me just say here, the square root of this, square root of that, okay, the whole of it. So r, which is pq, so you can say pq is equals to, what are you able to find? I'm able to find 19.50018624. And of course, if you round off this one, look at this, one decimal place. So we just put 5 there. So it will be 19.5 units in centimeter. So PQ is equals to 19.5 centimeter. So please make sure that you get to confirm the calculations and all that. We differ in the way we punch the calculator, but of course the procedure has to be shown. And as you can see, that is 5 marks. What you should avoid is cutting or rounding off. Immediately you start, finding the numbers, you start rounding off. Let's say this, you round off. At the end, you might have the answer that is not accurate. So write all the numbers, and of course, at the end, you round off. I guess that is clear. 5 marks for this. So you need to make sure that you show these steps. Okay, interested in the steps because each step earn you some marks. So don't leave out some spaces, or don't use the shortcut. That is 5 marks. Okay, now up to the second question, the area of the triangle PQR. Okay, the area of the triangle PQR. Here is the area. Here is the triangle PQR. Now, if you look at this triangle, it's a non-right angle triangle. Okay, it's a non-right angle triangle. Now, what is the formula that you've used to find the area of the non-right angle triangle? So I'm going to put this question here. So the formula is area is equals to half the two sides, which is Q. This side is Q, this side is P. Okay, so for the sake of order, we're going to say PQ. Then, of course, sine the angle that is given, which is R. So that is how you write the formula. But generally, it is area is equals to AB sine C. Okay, so now let us replace. So we have, this is 0.5 or just a half, multiplied by, what is our P? 12, multiplied by 12.5, multiplied by 8.9, then cos, is it cos, sine, what is the angle? 130.6. Why didn't we use this part that we found, which is 19.5? Why didn't we use this one? So these two should be the part that makes the angle the included angle. Okay, so the ones that are putting this angle in between are the ones that you use. Okay, so you use the angle and of course the two sides. Okay, so that is what you use. So in this one, if you multiply, you are going to have 42.23 4466 47 centimeter square. Area is in square, is square. Okay, you put square for area, so centimeter square. Then if you round off this one to one decimal place, simply going to be 42.2 centimeter square. That is the area. I guess you have gotten the formula here. This is Q. So that is how you simply calculate the area. Okay, let us see how we calculate now the third question, or let us answer the third question here. So for the third question is as the shortest distance. Find the shortest distance. From what? Shortest distance from R to PQ. So if you look at this, shortest distance is from R to PQ. So it is going here. So automatically here where they say in PQ, this PQ becomes your B. Okay, you're going to see in the formula for shortest distance. So now this is just more like height. Okay, or you can write SD for shortest distance, or H. Okay, so let us say shortest distance is equals to area times, 2 times area divide a base, which is this part where it is going. So now shortest distance is equals to 2 multiply area 42.2 divide what is the base, 19.5. And of course for this one you should be able to find when you divide, should be able to find 42. Is it 42? 4.3 to 820.5128. And if you round off this one, 1 decimal place, it will be 4.3 centimeter. It's a distance. Okay, so that is how you find the shortest distance. So we've answered question A up to question B now. So maybe I can clean this for the sake of creating space. Let me just clean up this part for the sake of creating space. Now, solve the equation B. So this is one of you requested that no, should do a video on solving the equation, that is a trigonometric equation. I hope to do some more questions. I'll have time. I think I will just have to compile some more questions so that you can see how it is done. Either way, we can learn something now. So now, for those who have no idea on this one, or those that might have forgotten, you should think of the quadrant. Okay, this is the 0 degree in terms of angles. This is 90. This is 180 degree. And of course, this is 270 degree. This is 360. So 0 and 360. These are quadrant. Now, for ratios that we have sine, we have cosine, and of course, we have tangent or tan. So let us consider these three. In the first quadrant here, from 0 to 90, all the trigonometric ratios are positive. So all of them are positive. So whichever angle that you find, okay, that is in the first quadrant for these should be positive. Then for a second part, only sine is positive. So only sine is positive, which means cosine is negative and also tan is negative. In the third quadrant, only tan is positive, which means they remain cosine, let me put sine, and cosine are negative. In the fourth quadrant, only cosine is positive, sine is negative, and of course tan is negative. Why am I giving you these? These are very important when you are given to answer the question or to solve the equation, because you are given now, you are going to determine whether you are looking for the positive angle or for the negative one for the ratio that you are given. Okay, so now aside from this, what else do you have to know? So the angle that you are finding, let us say, is the theta. So in the first quadrant, if the angle that you are finding is in the first quadrant, that is theta, it is just equal to the angle that you find. So let us say the angle that you find, which is the reference angle, we are going to name it alpha or x or alpha. So this is the reference angle. The reference angle is the angle that you find just after after calculating the value from the equation. But of course, the range is going to determine where you get the values. So in the first one, if part of the solution is from 0, the range, just know that the angle that you find is also part of the solution. But in the second quadrant, theta is equals to 180 minus the reference angle that you found. Okay? Then in the third quadrant, theta is equals to 180 plus the angle that you found. Then of course in this one, theta is equals to not 180 but 360 minus alpha. Alpha, I said, is the reference angle. Okay, so take note of that. Now, having this information, let us solve the equation. So to solve the equation, 2 sine x is equals to 1, which means the angle that you are finding is x. So we are going to divide 2. We are going to divide 2. So we have sine x is equals to, this is just the same as 0.5. Okay? Or you can leave it as half. Then now what next? We want to find the angle. So for us to find the angle x, we are going to say sine inverse, then 0.5. We punch this on the calculator. So x is giving us 30 degree. What did I say? This is the reference angle. Now look at this. They want the value of the theta from 90 to what? To 370. And the ratio that you are dealing with is sine. Now look at this part. This 0.5 is not negative, it is positive. So we are looking for the positive value of sine, but in the range from 90 to what? To 70. Okay? Now this is where most of you miss it. So which means this 30 that we've found is not part of the solution because it's not in the range 90 to 270. Okay? So we are going to look at where sine is positive in this range. And if we were to look at it from 90 to 270, it is from here up to there. This is where you find the second quadrant and of course the third quadrant. And only in the second quadrant is sine positive. And how do you find the angle? You say 180 minus the reference angle that you found. So therefore, to answer this question, the final answer will be theta is equals to 180 minus 30. And of course, the angle that we are finding is what? Is 150 degree. Okay. Now, let me just give an example. Let us say if it was in the range 0 less than or equal to x less than or equal to 360. We are going to consider where sine is positive in this range, which means in all four quadrants. And the first part is the first part, which is the 30 degree. So 30 degree was going to be part of the solution. Then where else? The second quadrant we said is 150 degree. Where else is sine positive? Nowhere else. So these were going to be the answers if at all it was in the range of this. Okay, so look out for that video. Okay, I'm going to create, because there are some of the values that you find as negative. What does it mean? So I'm going to explain all that part, but for now we can end here. All right, so I guess there's no problem on that part. Let us look at the C question now. For C question, simplify. So what are we going to do? So every time you are doing simplification or question like this, look at the possibility of factorizing something. So look at the numerator. Can you factorize it? Yes, you can factor out what is common. And in this case, what is common, I'll say is 3. I can say 3x. Then what remains is x squared minus, here, 6 divided 3 is a 2. So 2. We've removed 1x, so it will remain x. Then down here, it remains x squared, 2x. Because your factorization should read into cancelling something. Okay? You should look out for that. Okay? If there's no chance for that, then that is when you work out other things. But you should look at factorizing where the denominator looks as exactly as part of the numerator. I think that you've gotten it. So this and that cancels. And of course, what remains is just 3x. But of course, others would factorize it this way, where you say, okay, what is common is x squared, 3x squared. Then here, which means it was just going to be 3x squared, which means it was going to be x. Then of course here, it was just going to be a 2. Okay, then down here also we factorize. It was going to be x outside. Then of course x minus 2. You cancel out this. Then you are going to remain with 3x squared divide x. And of course here, 1x was going to go here with this x. Still remain 3x. So whichever way you go with, should be able to arrive at the answer. So we've answered question 9. Let us go to question question 12. Okay, so here is question 12, and of course it was on earth geometry as well as mesolation. The first part is earth geometry, and of course the second part is mesolation. So let us start with the first part for earth geometry. Now, some of you, this might be the first question or the first time you are seeing such kind of question, but anyway, if you've solved a lot of papers, I think you agree with me that there are such questions. Okay, so now the point P, 80 degree Newton, I mean 8 degree north. Why am I saying Newton? I'm used to physics anyway. 80 degree north, 50 degree west, that is 80 degree north, comma 50 degree west. That is the point. Q, 80 degree north, comma 80 degree east. R, 50 degree north, 80 degree what? East. And of course T. So now, for me, what I would do is, because here they're saying draw, sketch to represent the above information. So you're going to sketch and show these points. So for me, I'll pick what is common in terms of latitude. How many latitude do I need? And of course, longitude. Now, if I look at the first part, the longitude that is there is because these parts are normally latitude, comma, longitude. So the latitude is 80 degree north. What about in the second one? 80 degree north. So I know that 80 degree north, there are 2 points. Then of course 50 degree north. So I have 50 degree north. What else do I have? 50 degrees. So I only have 2 latitude that I have to put up. Then longitude, I have 50 degree west, which is this part, and of course 80 degree west. It's 80 degree east. Okay, what else do I have? It's just a repetition. So I only have also 2 longitudes. So this helps me to sketch the what? The information. So let me represent them. So I'm going to draw an oval shaped, okay, like this. Hope it will be enough. Let me just draw a smooth one. Hope I will be able to put up a smooth one. I guess this one is represented, at least it's fine. Okay, so let me start by putting the latitude. And you know that the latitude that move, this is the west, this is the east, this is the north, this is the south. Okay, for your own information. So now, in the middle, you have the equator. So I can put the equator so that as I put these other latitude, I will not put them in the middle here. So from the equator, which is 0 degree, going up, the latitude in terms of degree increases. So which means 80 is above compared to what? Compared to 50. So what follows is 50. So I'm going to put my 50. Okay, I can draw the other part showing that also on the other side. Okay, like that. So this is the 50 degree, okay, north of the equator, because the equator separates the globe into 2 hemispheres, the north and the south. So 50 is on the north. Then I can put up again another one, which is 80. And of course, I can label it like that as well. So this is 80 degree north. Okay, so I've drawn my latitudes. Okay, so please be able to put up a smooth one. Okay, then of course, for my longitude, I have 50 degree west. Okay, so which means west is this side. So I'm going to put 50 degree west. Okay, running up to that point. So I can even label this, okay, just putting a pointer, and this is the 50 degree west. Then of course I can put another one here on the other side. Okay, so for this one, for a sake of space, this is the 80 degree east, okay, to the east of the globe. So I've drawn, I've sketched, but let me put the points. So now, the first point is 80, 50. So on the north, we are on 280, which is this line, then comma what? Comma 50. So it is right here. So this is our P. Okay, so right here is our P. Let me just use a different color. So this is our P. Then of course we have also Q, which is 80, then east. So here is 80, and of course 80 degree east. So this is our point Q. Then what about point R? So for point R is 50 degree north and east. So it's on this side. So this is 50 degree north and of course 80 degree west. So this is our point. What is this point? Wow, I've ended up rubbing the other part now. Okay, hope I'll be able to pass. So let me just redraw this. Okay, I guess we've followed what I've done at what I did at first. Okay, so this point here is point what? Point R. Okay, this is point R. Then of course we have the last one, which is T, 50 degree north and of course 50 west. So this one here. So this is what? This is T. So this is where the sketching ends. Okay, so that is how the sketching should be. Okay, or just without the equator, just this part. Okay, then now what are the other questions? Calculate the distance QR along the longitude 80 degree east. So what they are telling you is that you are calculating the distance along the what? The great circle. You should know that distance is calculated along the great circle, also along the what? Along the small circle. So along the great circle, which is QR, as you can see, along the longitude 80 degree east, the formula that you use is distance equal to theta over 360 multiplied by 2 pi r, radius, where radius is given to be 6370. So you're calculating in what? In kilometer. But what about theta? So I want you to pay attention. How do you find the theta if you are calculating distance along the what? Along the great circle. So you normally find the difference in longitude. If they are on the same side, north-north, I mean you find the difference in latitude. If they are the same, north-north, you subtract. If they are south-south, you subtract. But in this case, what we have in terms of latitude, we have point Q is on 80 degree north and point R is on 50 degree north. So we are going to say 80 minus 50. That is our theta, which is 30. Okay, I guess you've gotten that. So distance is equals to 30 divide 360 multiplied by what? 2 pi. Okay, let me put pi. Pi is given as 3.142. So 3.142 multiplied by 6370, which is the what? The radius. Now, after multiplying here, what are you going to have? So here you can still reduce this 30 into 31, 30 into 360. This one should be able to give us 1 over 12. Okay, so if you want, you can reduce it that way. And of course, this one and that one can be 6. So which means what you have. So please, you can go direct, whichever way is easy to calculate. But of course, reducing paper 1 works. So you have 1 over 6 multiplied by 3.142 multiplied by 6370. Okay, so you can put this one in decimals first. You divide 1 divide 6, then you continue multiplying. I think that way is easy, okay, to avoid making mistakes. And when you punch this, should be able to give you 33.756667. Okay, 666 here, 7. And of course, since you are calculating distance or in the 8th geometry or on this particular topic, you need to write in 3 significant figures. Okay, so 3 significant figures, we are counting 1, 2, 3. So if the number that is ahead is 5 and above, you add a 1 here. So you're going to have 3, 3, 4, then here 0 kilometer. So this is the what? The answer. Okay. That is the answer for the first one, the distance along the great circle. Then let us find the distance for TR. Okay, so I'm rubbing this. So for TR, as you can see, let me just go back to the diagram. You see for yourself. So for TR, where is the diagram? Oh, we've cleaned it. Okay. So for TR is along the, I should have removed it. So for TR is along the what? Let me just try to bring it back. So this is, so it was like this. So TR, that is R was here, T was here. So for TR is along the latitude 50 degree north. It's even here. So RT is 50 is along the latitude 50 degree north in kilometer. That is, calculate the distance RT along the latitude 50 degree north in kilometers. So now the formula for distance along the small circles is distance is equals to theta over 360 multiplied by 2 pi r cos radius, or I mean cos latitude. So you can write cos latitude, others put cos x. You're going to find different letters being used here, but what you should know is that that is cos latitude, because for the angle you're going to use the latitude on which those points are found. Okay, so now how about theta? So if you are calculating the distance along the small circles, okay, along the latitude, just know that for theta is a difference in their longitudes. Okay, so this one is on the longitude 50 degree west, and of course this one is on the longitude 80 degree east. If they are on the same side, let's say it was west-west, you are going to subtract. If it was east-east, you are going to subtract. But since they are west-east, you are going to add. So 50 plus 80. So our theta is therefore 130. So distance is equals to 130 divide 360 multiplied by 2 pi r. Or let me just put the pi here. I think the diagram, we no longer need it. So the pi is 3.142. Then multiply by 6370. Then of course cos, the latitude is 50. So now if we are to multiply here, what are we able to find? What are we able to find if we are to multiply on the calculator? Okay, so what I'm able to find is 9291.459902 kilometer. Remember, 3 significant figures. Okay, so 1, 2, 3. So this is 1. Okay, so it's going to be 9290. Since this one is less than 5 kilometer. Okay, so please be able to confirm these numbers as you go through the recording. I hope you'll be able to also punch as you follow the video. Okay, so we are done with earth geometry. So we go to B question, which is on mesolation. Okay, so mesolation, paper 2, normally you find the frustum, whether either of the cone or the pyramid. But here what was given is the cone. So the figure below is the frustum of a cone. The base radius is 2 centimeter. Top radius is r, and of course the height is 3.6 centimeter. Take pi to be 3.142. So it's very important to read through the information that you are given. The first question is calculate the value of r if the height of a cone from which the frustum was made was 6 centimeter. Now, this one was one of this kind, I think, for the first time. Now, we are used to the one now we use the ratios to find, you know, the big height and the small height. But this one, the big height was given if we were to follow it properly. So big H was given to be 6 centimeter. And of course, the big radius was given to be 2 centimeter. Then of course, the small radius were not given, but the small height we can find. How can we find the small height? We are given the big height, and of course we are given height of this frustum. So what do we do? The big one minus this of the frustum, and we should be able to find 2.4. So that is the height of the small one. I guess you've gotten that. So centimeter. So now, having this information, let us find for r, small r. So we use the usual ratio of the big height, or we can say big radius divide small radius equal to big height over small height. Okay, so let us replace. The big height is 6 equal to the small radius we do not have. We're supposed to put the big radius here, which is 2. Then of course here, which is 6 over the small one is 2.4. We cross multiply, we are going to have 6r is equals to 2, that is 4.8, I guess. Then of course we divide 6, r, therefore we should be able to find 0.8, okay, centimeter. So we've answered the first question, that is for the radius. I guess there's no problem. Now, calculate the volume of the frustum. How do you find the volume of the frustum? Now, you know that the volume of the frustum generally is 1 over 3 pi r square h. Okay, pi r square h, I mean. Now, since we have two volumes, that of the big and of course the small, we can say volume 1 is that of 1 over 3 pi, that is big radius, then big height, that is square, minus, or let me say volume 2 is that of a small one, because we need to find the big one, then of course we subtract that of a small one. So here we are going to use small r and of course small h. Now this one we can incorporate it into one formula, but I like using them separately. Then at the end I subtract the solution. But if you can incorporate it, the formula of the frustum, the volume of the frustum will be pi over 3. Then in the bracket you are going to remain with what? R square h minus r square h. I guess also this one should be able to give you the same answer. So like I said, let us find the volume of the big one, V1. So for V1, 1 over 3, what is the pi? 3.142. Then multiply by the big radius. What was the big radius? 2 square. Then multiply by the big height, which is 6. If you multiply this one, after multiplying this one, you should be able to find 25.136 centimeter cubic. Now listen, if you are going to answer this one easily, make sure that you divide this one first, then you start multiplying this. It becomes easy. So 1 divide 3, it is more like 0.333. Then you continue multiplying without even removing this one on the calculator. I think it will be easy that way. Okay, so this is the volume of the big one. What about the volume of the small one? So V2 equal to 1 over 3 pi r square, then h. Okay, so 1 over 3 multiplied by 3.142 multiplied by the small radius. What is the small radius? Small radius is 0.8 square. Then of course the small height 2.4. Okay, I guess I've gotten this one right. After multiplying, should be able to give you 1.6. So be able to confirm these numbers. 8704 centimeter, and these are volumes cubic. Okay, then of course now you can subtract volume 1 minus volume what? Volume 2. That is the volume of the frustum. Okay, so you're going to have 25.136 centimeter cubic minus 1.68704 centimeter cubic. And of course, you are going to have what? 23.523796 3272 then of course 96 centimeter cubic. Now rounding this one into one into one decimal place, so you're going to have 23.5 centimeter cubic. This is the volume of the frustum. So if you had used this one directly, it was going to give you the same answer. Okay, so try out if it will give you the same answer. Otherwise, we can end here. And please, if you are interested in the online lessons, you can call the number 0976 402563. Okay, and those that are interested in the revision, I know few days are remaining, but still you can still do something. So you can still get in touch and of course register for revision. It can make a change. Otherwise, thank you very much for staying up to this point. And of course, don't forget to share the video. Don't forget also to tell others about this platform. See you in the next one.